This is a demonstration of the PETS Incorporated Rye Etching Plasma Cleaning Plasma Treatment System. It has a 12-inch diameter anodized aluminum chamber with a water-cooled stainless steel platinum electrode. Will process up to an 8-inch wafer or multiple smaller wafers. The RF power supply is an advanced energy PE 1000 low frequency, which has been limited to 625 watts maximum output. The system has 3 mass flow controllers. It is perfect for dielectric etching of silicon oxide, nitrides, silicone polyamides, and ashing of resist. It is a computer-controlled system including a flat panel monitor, wireless keyboard, and mouse. It is powered by 120 volts AC. Before we hook it up, before we power it up, let's take a look at all the connections in the rear. Now, this is the onboard computer. It is attached to the back of the flat screen. It is connected to the unit via an Ethernet cable. This is your connections for your actual RF generator, your output connector here, your power, and your control back from the unit itself. And while the computer is controlling it, it sends its commands into here, and it comes back and it completely remotely runs the RF generator. This is our compressed air hookup for controlling our valves. This is where you connect your vent, whether that be typically connected to nitrogen. The vent is normally somewhere between 5 to 10 psi. Over here, it is, as I mentioned, a water-cooled unit. You have water in and water out. In the middle, of course, here is our main vacuum connection. Here's our power, a main fuse. This is a ground that is also and should be grounded to the RF generator as well. And these are the 4 gas inputs. D is not being used, it's not connected inside. But we have A, B, and C. We step over here just to take a quick look. What I've arranged for our demonstration is this is our chiller, and even though we typically use different process gases, for our demonstration we're just going to use argon. So now, while we're back here, we're going to turn everything on. The piece of equipment includes a brand new rebuilt pump that is more than adequate for pumping. We will turn that on here. To turn everything on, turn on this button right here. It turns on the main module. As we walk around, this is the power button for the computer itself. You see the lights go on. And one more switch would be the front panel switch on the RF generator. Now, this has been modified. Typically, this is 1250 watts, but this particular unit has been modified to only go up to 625 watts. It also cannot be manually operated. It is strictly made to work with this equipment. Now, the next thing is, don't forget to turn on your chiller. Your chiller should be set anywhere between 15 to 20 degrees C. Now, before we start, the manual is very good. It explains everything you need to know about installation as far as the connections, the water. It's a very small line that runs through here, but you still have to have close to 1 gallon per minute. And if we were to look, just peek through here, you'll see our flow gauge that we are just about at 1 gallon per minute. Now, to start the software, we go right here to PETS, Plasma Equipment Technical Services. When the home page comes up, we go right here to Rise Software. It will quickly initialize. Now, this is very simple layout and it works very well. First, we have up here our process gases. Each one of these can be set individually in manual mode for a specific amount of volume. Here is our vent valve going in to the top of our chamber. This is our vacuum control. There is a vacuum interlock here that will turn to green once you pass the point that you set here on this scale. So you can set that at any place you want. This is control over your roughing valve that goes directly into the chamber. On this side we have system operation. Again, this can be run in both manual and automatic. There is a stopwatch and you can also set your own elapsed time in here as well. On the bottom here, these two are disabled right now. This one is not disabled, but this one is. If you hit system, it'll come up and tell you about some of the configurations of your system, such as, for example, the gas box, what full-scale measurements are, the power supply, and upstream pressure, letting you know when you hit that threshold point where things will start operating. Also, here is where you would start and stop automatic programs that you'd run. We're going to run in manual first, then we're going to run a program. So we would start by, we've already vented our chamber, so we'll pump our chamber down. Now once it passes 2.4 torr, our interlock has been satisfied. Because we have our chiller on, our water has been satisfied as well. And typically we wait till around 50 millitorr before opening any process gas valves. So we're pumping down from atmosphere all the way down to 50 millitorr. Manual is very handy because what manual operation allows you to do is experiment a little bit with your workpiece in here and get the right settings that you need. Then you can take those settings and turn it into an actual saved recipe for your particular process. All right, we're down below 50, we're down to 43 here. I'm going to go over here to sulfur hexafluoride, I believe I said that right, and we're going to manually open this valve. Now each time you open a valve, you'll notice we have this nice little graphics here that allows you to know that yes, one of our valves is open. Then you can set this at any range. I'm just going to set this up a little bit right to here. And you notice that our pressure in our chamber is going up while it's still pumping. And that is part of the normal process. You get to a point where it's stable, such as it is here. Got to give it a little time. And then we'll turn on our power supply. I'm just going to start off by putting it here. And we go on. Now, if we look over at our power supply, oh, I hit it right on 200. We'll see that we're running at 200 watts. We have our valve 3 open, which is our sulfur hexafluoride. And as you can see, we have a nice, healthy glow in pinkish purple. And you can run this as long as you like. While actually, if you're a process engineer, while setting this up, you know, if you need to know how long, you can run your little stopwatch here and say, okay, I need to run the plasma for 1 minute, 2 minutes, or whatever at a certain wattage. When you're done, you turn off the power. Notice it turns the power off here. I think these graphics are excellent because they always let you know where you are. You can close your valve and you can close your roughing valve and vent your chamber. The chamber with very little pressure takes approximately 20 to 30 seconds to vent to atmosphere. Once you have a little pressure applied from, for example, from your nitrogen purge, it'll vent a little bit quicker. Reset our clock here. We open our chamber. Here's our platen. Always check this O-ring and try to keep the surfaces clean. We'll close our chamber, but this time we're going to run it in automatic. So what I just did in manual, stepping through the valves, and very importantly when you're running in automatic, waiting for the correct vacuum level. You can't be turning on the RF generator without it at least being down into the millitorr range. So what we're going to do here now is we're going to load one of the programs here. All right, I have this one here, which we'll accept. Now, before we run the program, let me show it to you. It'll scroll by here as it's actually running the machine. But if I hit edit and I go back to accept, we can see it. Now, this is called Visual Basic. It's been around since 1991 and it's still widely used. And even though it's structured in the typical Windows notebook, this has complete control when the program is run. I'm going to step through this one first just so you can see it. You can make changes to it. If you wanted to change this to 300, you could. So it is completely editable. In this particular program, what I'm going to do is I'm going to run 200 watts, have the RF generator on up to 200 watts for 2 minutes on my workpiece. Shut down all, the way the program runs and the way you set them up. And once you take one of the existing programs in there, you can use it as a model and you can then select what you want to change or add in the program. Let's take a look at this one. First, low frequency refers to the low frequency power supply. This is a 40 kilohertz power supply, not a 13.57 megahertz. So this is low frequency power supply. Low frequency set point is 0. Our power supply is turned off. We wait for 1 second. We make sure all 4 of our gas valves are set points are turned off. Even though we know that we're not using this one, we still set it anyhow. Then we make sure that all 4 of our gas valves are closed. We must have that instruction first for the program to understand what it's to do next. Wait for 1 second. We ensure that all the valves are closed. Notice I left this vent valve open. I closed that real quick. Now, notice that all the valves are closed. Then, after all the valves are closed, we chamber is nearly vented. Then we pump the chamber to the base pressure. We turn the roughing valve on We wait for 5 seconds, and then we allow the roughing valve to pump the system until we're down below 50 millitorr. Once the chamber has been prepared, we then move on to the actual process. We begin the process, we have to establish chamber pressure, which would be your working vacuum level for running your process. We open our third gas valve, which is CF6. We set the set point for 2.25. Wait for 2 seconds. Make sure that the third gas valve is closed. Move on to the next gas open. Wait for 20 seconds. Wait till we reach a certain pressure. And once that pressure is reached, the stopwatch, not the elapsed time that you can set and use in your manual mode, but the stopwatch used in the automatic mode to time the actual amount of time that the RF generator will be on. So we're going to count down on the stopwatch for 120 seconds, and then we're going to start the stopwatch. Now we need to establish our plasma. As we said, we're going to run at 200. So we're going to set our plasma set point for 30%. It's expressed in percent. 30% of 625 is about 206 watts. Again, we're going to let it run for 120 seconds until the stopwatch stops. Then we are going to reset our set point to 0. We are going to turn off our RF generator, and we're going to wait 10 seconds to let everything cool down. It does get warm. You can actually put your hand on top of here, and even after running for a few minutes with the cooling on, not dangerously, but you'll feel it gets warm, so that cooling is very important. Then we're going to make sure all of our set points, once again, are closed for our gas valves. We're going to wait 20 seconds. We're going to make sure that all of our gas valves are physically off, and then the program will stop. That's what this will do. So now we have that program in place. It still says manual, but once you hit the start button, it will switch to automatic mode. Now, you can stop it at any time, or you can pause it right where it is and hold it and then resume. So, now right now, I had this set in manual. I'm going to set it all the way down here because it will set your RF output. It will set, open and close your valves and set the correct level as well. All you have to do is hit start. So here we go. You're going to now watch that program run in automatic. We're going to put it all the way up at the top here and hit start. It will sequence, and we open our roughing valve, and we're now going to wait for it to get down to 50 millitorr. The program, of course, will wait till then, but I sort of like to explain as we go along here. Notice that it has opened SF6 to approximately 10% of its scale. It's waiting a full 20 seconds to allow the pressure to stabilize, just like we saw in manual operation. And after that 20 seconds, it will turn the RF on. We go on over here That's pretty good. That's just about 30%. 207 watts. Again, we have a nice, healthy, clean glow here as well. This actual generator will go up to, as I've tested it, 651 watts. So it's got plenty of power to carry out the type of process that you'll be using. So we're just going to wait for a few minutes, and we're going to allow this to go through its full cycle. This will count down to 0, and then at that point it will go through the process just like in manual of closing the different valves, allowing things to relax, if you will, and then it will vent. No, it won't. You have to vent the chamber, but it'll get to a point where it will change back here. Pardon the mistake. When it's running an automatic, you can't do anything. It nulls out all of the manual controls. You can't push on any buttons here and make anything happen. They're completely turned off in automatic. However, at the completion of any one of the automatic recipes, it will turn back to manual. And at that point, you have full and complete control. There's about 12.5 recipes from the previous user of this that was a dedicated rye etched user, and it's a good model to use. You can pull some of these up, make changes in them, save those changes, see if that produces the results you want, put them back. So it's pretty simple to make changes. While we're waiting here, Visual Basic and how to make changes is clearly explained in the book. Now, we have ended. For some reason, it comes up with a 2 once in a while. Nothing to really worry about. And at this point now, you're done. With that automatic mode, you can close your valve and you can open your chamber. While we're waiting for it to vent, I'll go back to our book. Here is the description on how to use it in the manual, in the automatic mode. Pay close attention to this and reference these pages here as far as how to use the text and the mnemonics as well. This is a good note here. Operating in manual mode bypasses some interlocks. Use extreme caution. Again, what we're really referring to is the vacuum level. You cannot operate an RF generator at atmosphere. So be very careful to follow the guidelines of always getting down to at least 50 millitorr in manual before you turn on your gas valves. There's a complete section on how to operate it in both automatic and manual. And as I mentioned earlier, there is a complete installation guide as well. So you shouldn't have any problems if you follow the manual. Now, we are back to atmosphere. And for the last part of our demonstration, I'm going to run it in manual one more time. We'll close the vent valve. We'll open the chamber and let it pump down. While we're letting it pump down, something interesting. This is actually a very classic piece of equipment. If you look over here, this is a classic Techniques PE2A. I've worked on many of these machines before. Its controls are somewhat semi-automatic, and they're all in the bottom here. This very, very clever manufacturer has taken the standard Techniques Etcher, and has computerized it. It's very simple and it works very well. It still has the same type of performance as you get from a Techniques, It is actually a Technique's head, if you will. And coupled with an advanced energy power supply, it's very, very reliable. Now, when we go back here, I'm going to now open this valve up to, let's run it up a little bit. Now notice the vacuum level is going up. As long as you don't go over 2.4, it won't shut down. But typically, I do my demonstrations below 1 torr. So it's settled nicely at about 645 millitorr. I am going to turn on our power here. We'll start off with right there. And we're at 143, pardon me. Now, this is a nice display here. It typically, within 1 or 2 digits, matches the monitor on here perfectly. Just so you can see our maximum power, we're going to run this up, pardon me. Run it up some more. A little bit more. And we're going to peg it. It does not arc, it's not over temp. It seems to be doing very well. It's staying fairly cool. And we can get 651 watts out of this power supply. We'll turn it off and we'll bounce it back on again. Boom. All right. And once again, we will turn it off. We will close our valves. And again, just so you can see the effect that the valves have on the vacuum. Because remember, they may say 10 to 100%, but if you actually look at them, you'll see that their full scales are somewhat different. So when you go to use them, you'll see that, whoa, the vacuum opened a lot more with this one than this one. That's because you can set the mass flow controllers any way you want. And we will vent our chamber. Whoop. Now notice, I tried to vent the chamber here in manual, and it won't let me do it. Even though it's in manual, as you can see, it's in manual, I forgot to close my roughing valve. Now you'll be allowed to vent. It's a very simple system to use. Take the time to study Microsoft's Visual Basic programming a little bit, and you'll find yourself running up and down that recipe without too much problem. You have to tell it everything. It is an automatic operation, but in the software itself, as I stepped you through earlier, make sure you open and close your valves correctly. Make sure you have your correct trip points for your vacuum correctly, and you'll have a very, very good machine here. It'll work very well for you. And this completes this demonstration.